Hi, all you cool cats and kittens. This is Miss Cunningham here. We are going to get started on our next lesson, 10.2, Find Arc Measures. Okay, so you can print off these notes, which are on my website. You can grab your notebook and take notes and follow along. Just make sure you are doing the best you can to learn this section. And obviously, you can pause whenever you need so that you can work on the problems on your own and then check your answers once you press play. Let's do it. All right, guys, so let's do a lot of vocabulary. A central angle is when it's an angle whose vertex is the center of the circle. So this is circle C here, okay? So we got angle ACB, which is referred to here. We call this a central angle because it's coming from the center. Notice the two legs of this angle are radii, okay? Now, what we also have are arcs. So once you have a central angle coming in, you have it cut into arcs. A minor arc, they're calling this in red, and then a major arc, they're calling this in blue. Now, the biggest difference is a minor arc is less than 180 degrees, and a major arc is greater than 180 degrees. So some things to note with that is, I'm trying to get my annotate tool so I can annotate here. Okay. Where is my drawing tool? Okay. So a minor arc is less than 180, and it is usually named with two letters. Okay. And then an arc over it. So look at here in red, minor arc AB, and then the symbol to let us know it's an arc is this curvature over AB. Now a major arc is always named with three letters. So that's how you can always know it's a major arc. Look here, major arc ADB. So that means start at A, go through D, end at B. You know what? I'm going to actually say this is usually as well. I've seen some minor arcs named with three letters. The main thing is, though, if they just give you two letters, that means go the quickest route. So when they say arc AB, you could go this way, or you could go the long way. But because it's two letters, go the quickest route, which is AB, okay? We'll see lots of examples, but we'll see how that comes up more. So an arc with endpoints that create a diameter of a circle. So for example, if it looked like this, you have a straight line going through your center so that you have this entire half of the circle cut off as an arc. We call that a semicircle. It's the arc with endpoints that are the endpoints of a diameter. So a diameter cuts through and obviously cuts your circle in half, making it a semicircle. Now let's actually measure the arcs. So this is kept very simple and literal. If the inner angle is 50 degrees, so the central angle is 50 degrees, the arc that it cuts off is also 50 degrees. So you can see measure of angle AB equals 50 degrees. This little m that's italicized in front means measure of. Measure of arc AB is 50 degrees. So with that, that's actually enough information for me to find the major arc, arc ADB. We know a full circle is 360. So what they're doing down here is 360 minus 50 would give me 310. So that means my major arc is 310. I'm drawing a little arrow here. Minor arc's 50, major arc is 310. 310 plus 50 is 360, a full circle. Okay, now this is asking us to find the measure of each arc of circle P where RT is a diameter. Okay, RT being a diameter tells me a lot. That means I have two semicircles. So I'm actually going to write down that this entire half is 180 degrees because you don't want to forget that. So that also means that this entire half is 180 degrees. So if this entire half is 180 degrees, 180 minus 110, that would make this have to be 70 degrees. And to be even more exact, if this central angle is 110, this arc is 110. If this central angle is 70, this arc 70. And if this arc is 180, this central angle is 180, which would make sense because look at, it's on a line, which is the diameter. So now let's answer the questions. Find the angle, find the measurement of arc RS. RS. So I know to go the short route because it's 2 letters. Because you could go the long way, which would make it major, or the short way, which makes it minor. So RS would be 110 degrees. Find the measurement of arc RTS. So that means go the long way. RTS. So that would be 180 plus 170, which equals 250. Oops. Equals 250. You could have also done 360 minus 110, and that would have given you 250 as well. Okay, for C, find the measurement arc RST. So that means start at R, go through S, end at T. Okay, so that's clearly, you're capturing 110 plus 70, so that's 180. That's actually a semicircle, 180 degrees. Okay, let's keep going. Okay, adjacent arcs. We've seen this word before. Adjacent means next to. When we were actually in the classroom, you were adjacent to your pod partner. So it just means next to. So here we have adjacent arcs. Arc AB is adjacent to arc BC. And you know, arc CA is adjacent to AB and all that. They're next to. So what this is telling us is that you can add arcs. Okay, that's not anything new. We were just subtracting arcs on the above slide. So this shouldn't be a groundbreaking postulate or anything. It's what allows us to add arcs. All right, so why don't you pause this and you try to answer the questions A through D and then push play when you're ready for the answers. A recent survey asked teenagers if they would rather meet a famous musician, athlete, actor, inventor, or other person. Maybe meet online now these days, huh? The results are shown in the circle graph. Find the indicated arc measures. So they want the measurement of arc AC, 2 letters, so that tells me it's minor. Okay, so that would be A to C. Remember, go the short route. Don't go the long way. That would make it major. So that would be 108 plus 29. And yes, I'm going to be using my calculator because you guys have seen me do mental math and it can get scary. So let me calculate this. 108 plus 29, that gives me 137. Okay, let's do B. They want the measurement of arc ACD. That's major. So let's see, that would be starting at A, going through C, stopping at D. So that means I would be adding up all those little segments. So that would be 29 plus 108. Oh, that's not a 2. 29 plus 108 plus 83 plus 61. So let's go ahead and add that up. 29 plus 108 plus 83 plus 61. I got 281. You could have also done 360 and subtract out the 2 arcs that you don't want. So you could do 360 minus 79 and 61, and you should still get the same answer, which I'm going to check because maybe I'm wrong here. Maybe I entered in a wrong number. Oh, I am wrong. Why did I add 61 here? I guess I just got excited and wanted to add 61, which should not be included in here. So actually edit, let me just erase that. It should be, oh, I'm glad I did a double check here. 29 plus 108. You guys would have been emailing me. Was 83. So that would give me 220. Okay. Now C, find the measurement of arc ADC. Okay. So that would be starting at A, going through D, ending at C. Okay. So I am actually going to go about this one a little different. I'm going to use 360 and subtract. So I'm going to do 360 and I'm going to subtract 29 and subtract 108 because these are the two pieces I don't want. And then that would give me 223. Now for D, it wants the measurement of arc EDB. So that would be EDB. All right, so I'm again going to do the 360 minus because that's the quicker way to do it. So it's going to be 360 minus 29 minus 79. I got 252. If you wanted to add those up and just make sure you still get 252, that's a good way to check. Another quick thing I'll do is I'll add 1 plus 3 plus 8 and just make sure it ends in a 2. And that's, you know, just a quick on the go kind of check. Okay. So this is a great one. Why don't you pause this and try and answer 1 through 6 and then push play when you are ready for the answers. Okay, so it wants two things. It wants me to identify the arc as major, minor, or semi, and then find the measure of the arc. So remember, major means greater than 180 and minor means less than 180. Okay, so greater than 180 and less than 180. And then semicircle means exactly 180. So they want the measure of angle TQ. T to Q. Well, if my central angle is 120, so is the arc. So this would be 120. And you know what? I want to go ahead and find arc RS, or the central angle here, because it's the one piece that's missing. Do not just assume that it's vertical angles here, because this line S to the center is not a straight line from the center to Q. So this would not be a vertical angle here, okay? Don't fall for that. We're going to see if TR, well, TR is a diameter because 120 plus 60 is 180. So that tells me that this is a semicircle and this is a semicircle. So this is a straight line here, okay? Let's do 360 minus these three numbers to go ahead and find our missing angle. So 360 minus 80 minus 120 minus 60, and I got this angle to here to be 100, which means the arc is also 100. All right, now they want the measurement of arc QRT, Q to R to T. So that would be everything except 120. So the quicker way to go about this would be 360 minus 120, and that is 240. Okay, now they want the measurement of arc TQR. Let's see. So that would be from T to Q to R. Oh, so that's 120 plus 60, that's 180. Now they want QS. Okay, so it's two letters, guys. So that means the shorter route, the minor way, which I realize I have to go and name all of these, which I'll name all of them at the end. So Q to S, here's the long way, and here's the short way. So Q to S, the short way would be 100 plus 60, so that would be 160. TS, the short way, would be T to S, that would be 80 degrees. And then arc RST, so that's the long way, RST. Well, and when it's 3 letters, you don't really have options. You have to go through R to hit T, or through S to hit T. So RST would be 100 plus 80. That's 180. All right, let's go ahead and name these. Let me change my color. So 120 is less than 180, so that's minor. 240 is greater than 180, so that's major. 180, 3 and 6 would be semicircle. They're both 180. 160 is less than 180, so minor. 80 is obviously less than 180, so also minor. All right. Good job, guys. Let's keep going. This is a shorter lesson than 10.1. All right, congruent circles. So circles can be congruent if and only if they have the same radius. Okay, and then for congruent arcs, if they have the same measure and they are arcs of the same circle or congruent circles. So in other words, that's a mouthful sentence. To be congruent arcs, they have to satisfy 2 things. They have to be from congruent circles or the same circle, because the same circle is congruent to itself, and have to have the same exact measurement. So let's go ahead and look through, talk about A, B, and C here. So A, tell whether the red arcs are congruent. So it has to satisfy 2 things. It has to be from either the same circle or congruent circles. So it's from the same circle. And then they have to be the same measurement. So 80 is congruent to 80. So obviously then this would be a yes. Explain why or why not. Yes. I want to scroll down a little bit so I have more room to write. Yes. Same circle and congruent central angles. Okay. B, tell whether the red arcs are congruent here. So we've got a small circle here inside and then a bigger circle here on the outside. This has a special name when they share the center. We talked about this in 10.1. Does anybody know the name? Starts with a C. These are called concentric circles. So just to bring some vocab back to us, they share the same center, like a dartboard. Okay, so first of all, guys, concentric circles are not congruent. So these arcs are not on congruent circles. So no, these arcs aren't congruent. No, not on congruent. All right, let's look at C. Are these red arcs congruent? So the first thing I want to make sure they're on different circles. Are these circles congruent? For the circles to be congruent, they have to have the same radius. Yes, they do, because look at their mark. So they are on the same circle, or sorry, they're on congruent circles, and they're both 95 degrees. So this is yes, congruent circles and congruent. Okay, let's delete this and get to our next example. So why don't you pause and try these 2, and then we'll pick back up when you're ready. All right, number 7, tell whether the red arcs are congruent. Well, 1, they're on congruent circles because they have the same radii. 2, they're the same arc measurement, central angle measurement. So yes, congruent circles and congruent. Ooh, I want to spell angel every time. Just like my best friend spells them. All right, now are these 2 arcs the same? Well, first let's check if they're on congruent circles. This radius here is 5, this radius here is 4. So no, not congruent circles. Yes, I can see they have the same central angle, but if they're not on congruent circles, these would not be the same. This is like the idea of like how much pizza crust is here. So say this is a medium pizza and this is a small pizza. This is going to be a lot more pizza crust here than the small pizza. So it wouldn't be the same. Now, if you just order 2 large pizzas and you cut out the exact same degree measurement in both pizzas, yeah, they'd be exactly the same. All right, let's keep going. Oh, we reached the finish. All right, guys. Well, I wish you a wonderful day. You can always email me with questions, and please do your assigned homework that is on my website. Thank you so much, and I miss you all.